There are several features that I want to make sure we become familiar with on the Nexus platform. These features offer very important benefits to the data center environment. When I think of these features, I like to classify them in three different areas of the OSI model. Now, this is by no means all-encompassing, or is it an exact science, so you might not agree with this, and that's fine. This is how I like to remember these features. First, there's a feature called Virtual Device Context, and we'll talk about that feature a little bit more in depth later, but what we're actually doing is we're actually taking a physical device and dividing it up into virtual switches. These virtual switches are just that. They have their own processes, they have their own VLANs, they have their own configuration, they have their own routing, they have their own management, they have their own everything. So I like to think of it as we're actually physically splitting that up, and because the OSI layer 1 is the physical area of the model, I call it layer 1 virtualization because that's how I can remember it more easily. The second type of virtualization in the Nexus platform is layer 2 virtualization, or what we like to call VLANs, or virtual local area networks. I suppose if you're using FCOE, you could also include vSANs in this as well. I'm not going to cover the VLANs in depth because I actually covered it in the 640-911 course. If you're not familiar with VLANs, please download some of those chapters and review it there. The second layer 2 technology I'd like to talk about is virtual port channels. A virtual port channel is a virtualization feature that actually makes two Nexus switches look virtually like one switch, and it gives us certain advantages in the data center. The final feature is a layer 3 feature called virtual routing and forwarding, or VRFs. What VRFs do is allow us to create virtual instances of routing. So I can have a production VRF and an accounting VRF, and they won't talk to each other unless I route between them. So I can actually have two different routed networks going on inside my Nexus device that I can virtualize with virtual routing and forwarding. So let's talk about Nexus Virtual Device Context. As I stated before, Nexus Virtual Device Contexts is the concept of taking a single physical box and creating multiple virtual switches. When I create a new VDC, or Virtual Device Context, I'm actually creating a new virtual instance of that switch. And you'll see later on in these lessons that when I start that up, I get my own setup prompt, I get my own VLANs, I get my own IP addresses. Everything is unique to that device on that box, besides the underlying version of the operating system that is running on it, which is NXOS. I can then create another VDC, so I might have VDC1 and VDC2. When I create that VDC, I actually have to allocate ports from the line cards to that specific VDC, and those individual virtual switches will only have use of those ports. In order for those virtual switches to communicate, they are so separated that I actually have to route a physical cable between the ports in VDC1 and VDC2 to make information go between those device contexts. So virtual device context can be a great feature to use. For instance, if I have a production network and a backup network, and I want to keep those completely separate, I might create two VDCs. If I want to use a feature like OTV, there's a dependency to actually create another VDC. So I would have an OTV VDC and I would have a production VDC. There's a lot of different reasons to use VDCs, and we'll explore that later on in other lessons. The next feature I want to take a look at is Nexus Virtual Port Channels. Now traditionally, with a data center architecture, I want to have as much high availability as I can. So I actually might link these two Nexus devices together, and then if I have a southbound switch, say this is my aggregation layer, I might have a switch from the access layer that I want to connect up to these two Nexus devices. When I do that, Spanning Tree is going to take over and say that I have a loop, and it's going to block one of the links. Therefore, I get a redundant environment, but I don't get full access to all of my bandwidth. What virtual port channels enables me to do is actually create a virtual instance of a switch, and it makes both of my Nexus 7K1 and 7K2, or 5K1 and 2, look like a single virtual switch. And this way, the Nexus 5K below it sees a single switch and can unblock that link because there's no longer a loop. It's connected to the same device instead of two different devices. Virtual port channels is a very useful feature inside of today's data centers, and we'll cover it more in depth in later lessons. Please join me for our next lesson, Examining Nexus Licensing.